so that probably explains some of it. All right, factor state restrictions, cancel anything you can. Where are we up to, by the way? For some reason I got skipped, that's fine. Curtis, can you please factor the numerator? What does the numerator turn into? Yeah, x is factored out, x is common. What's left inside the brackets? 2 take away x, good. Georgie, x squared plus x. Factor that for me, please. Good. Okay, I'm not going to pick on Ben, but I could if he wants to take it. Ben, how do you feel about restrictions?
Take it. Negative 2, and
okay, just separate.
2 and
okay, he's just always like, shh, we both do this. Okay, this. Where does the zeros? Guys, let's do this. Where do the zeros cause problems? In the denominator. So Ben said 2. We don't even need to worry about this. Hey, stop. This up here, you don't even care about the numerator here, just the denominator. So what would make x 0? What can x not be to make x 0? No, negative 1 would be fine. Negative 1 would be work for this, okay? So this right here says x cannot equal negative 1, right? From right there. Is that a hand? What's the other one going to be? Oh. What's this one going to be? What's going to cause the problem with this one? No, 2 is going to be fine. 0. X cannot be 0. Okay, now we cancel anything that we can. What's common in the numerator and the denominator? X. Okay. So x and x are gone. So our final answer is going to be, I'll go to the top so you guys can see. The final answer is going to equal 2 minus x all over x plus 1, where x cannot equal 0 and negative 1. Now I'm going to let you guys write that down and ask the question that every class ever has asked me, but we'll see if you ask it around these people. Yeah, I'll answer the question that no one's going to ask me here today. The question was, sorry, you got it? Go ahead.
Yeah, it says that the bracket's not there.
That was the question I was going to ask, okay? If you take a look here, if you plug 0 into this final equation, because I wrote here x can't be 0 and x can't be negative 1, right? If you plug 0 into this equation, you'll get, well, 2 minus 0 is 2, and 0 plus 1 is 1, so 2 divided by 1 is 2. All is good. The problem was, because it's supposed to be equivalent all the way up with these, if there's a problem with the variable any way through, it's a problem with the final answer, okay? Because it's equivalent to this. And we'll show in a few seconds what that would actually look like on a graph. What if I were to graph this? Would be like this, okay? Where it looks like this graph here, except where there's a problem at a certain point. But we won't do graphing today, so don't freak out about that. Okay. As far as example 4 went, please ask right now before I move on to example 5. Yeah, okay, Cal.
So why isn't negative 2 a restriction?
Good question. Because negative 2, if we plug in negative 2, the denominator is not 0. It's only the denominator that we care about. The new, like a 0 over something's fine, right? It has to be divided by 0, it's the only issue. All right. Anybody else before I keep moving here? You ready? All right, example 5. Simplifying state restrictions. Let's go x squared minus 16 x squared plus 5x. Okay, I'm going to hit pause in the video. I'm going to give everyone a few seconds to try this out. I'm going to give you the instructions before you freak out. The instructions are, look at the left-hand board. Can I get somebody to be brave and read me the 3 steps? Step number 1 is factor. You always factor first. What do you do after you factor? Very good. Then you're going to state restrictions. What are you going to finally do? Good. Okay. Right. So start off by factoring always. If you don't know, here's a little life lesson for you guys in math. If you don't know what to do when you're given a problem, you start by factoring. You can't go wrong with that, right? You don't know what to do, factor.
What if you can't factor?
Quad formula. Don't ever say that Thomas Relacer said that, okay? Colton, show your factoring, please. Skills, please. Go ahead.
So it's x minus 4.
Yeah. Very good. As an aside, okay, guys, can I please do this? Okay, on the denominator, and in every question you do in this class, there's going to be a lot of factoring. If you remember our first question we did, guys, can I talk here, please? When I gave a list, when I gave...
It's Thursday.
Focus, please. I gotta get through this, okay? If when you guys, I'm not giving up yet. I'm not giving up yet. If when you do this on your test or your quiz or your assignment, okay, for this, some people what they do is they'll put like a little A here and then do their factoring part for the numerator here, then put a B and do it all separate and bring it back together. I'm going to do the shortcut for this, although I shouldn't. I'm going to say I mean Kylie. Kylie, can you tell me what this is going to factor out to, please? What multiplies to 4 and adds to -5? Okay, guys, can you please stop? Matt, you said you wouldn't talk when you're back there. No, so don't talk when you're back there. Okay? Okay, so that's going to be, which day was it? -4, -1. The shortcut is going to be x minus 1 and x minus 4. Okay. All right, that we can do a decomposition if you really need to. Can I get a brave soul who's feeling good about restrictions? So tell me the restrictions on x here, please. Lily, go. It's your turn anyway. Go ahead. This right here causes a problem for x not equal 4, right? This one right here causes a problem for x not equal 1. Taylor, what is common, please, between the numerator and the denominator?
Oh.
Taylor? I don't know. Somebody help me. What's the same at the top and the bottom? Yeah. Now, I was asked this question by David. Since you raise your hand, I'm going to tell the class that I helped you with this one. Okay? The x minus 4's cancel out. Because the +4 and the -4 they're not the same, right? So you can't cross those out. All right. What some people do is say there's an x, I cross an x and x. No, you can't. You have to factor the entire bracket like you're dividing. So my final answer here is going to be x plus 4 divided by x minus 1, where x cannot equal 4 and 1. Okay, questions and fears before we try something a little more awesome. Yes?
Even though you got rid of the 4, can I still not?
Yeah. So this is the same thing. The good question. I answered this one before, but I'll answer it again. It's okay, Brooke. The question was, even though there's... Stop your hands, please. Okay. The question was, why can x still not equal 4? Because if it's a problem here or here, the problems still carry on. It's supposed to be equivalent, right? So if there's a problem at any step, it continues to be a problem at the end. All right, let's do maybe one more. Simplified state restrictions.
I gotta get a new page.
Okay, try that one for me, folks. Of course you can do this.